Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use density as a conversion factor to convert from one unit to the other, especially between grams and milliliters. So let's get into this. So as we know, density is equal to mass over volume. So because there's a relationship in density between mass and volume, you can use density as a conversion factor to convert between masses and volumes. And typically, density is going to be given in grams per milliliter. So you can always convert. If you have the density in grams per milliliter, then you can use that to convert between grams and milliliters. So let's go over a few examples so I can show you how this is done. So the first problem is, what is the mass in grams of 75 milliliters of water at 20 degrees Celsius? We need the density of water at 20 degrees Celsius. So you might know that water has a density of 1 gram per mil, but that depends on the temperature. So water's density is going to change depending on how hot or how cold it is. So this is 20 degrees. So we're given that the density of water at 20 degrees is just below 0.9982 grams per milliliter. So we can use that to help us convert 75.0 milliliters of water to grams. So we're going to always start with what you're given. You're given 75.0 milliliters. So here we got 75.0 milliliters on the top. We're going to put that over 1. And then we're going to use our density as a conversion factor. Since I have milliliters on the top, I want milliliters on the bottom. So I have 0.9982 grams per 1 milliliter. So 1 milliliter is going to go on the bottom. And the 0.9982 grams is on top. 0.9928, and that's grams. So milliliters will cancel out. And then when I calculate that out, I get 74.9. So 74.9 grams of water. And as you can see, my answer has 3 sig figs because we're multiplying and dividing. And the rule is that your answer should have the same number of sig figs as the least number of sig figs in your measurements. So here I have 3 sig figs here. I have 4 here. 3 is less than 4. So I make sure that I have 3 sig figs in my answer. Okay, next we have number 2. What is the volume of 25.00 kilograms of water? So now we're going in the opposite direction. So we're given a mass and we want to get to volume. In this case, we're going to convert to liters because we're given a very large kind of unit here. Kilograms is a larger unit, so it makes sense to convert this to liters. So we're going to start with 25.00 kilograms of water. And then we're going to convert this to liters. So we want to get this to a volume unit. We're given kilograms. Our density is going to be 0.9982 grams per milliliter. I have grams here, so I can't use this unless I have mass in grams. So I'm going to have to convert kilograms to grams first. So I know that 1,000 grams is equal to a kilogram because kilo is 1,000. Okay, so I'm going to put 1 kilogram on the bottom and 1,000 grams on top. Kilograms cancels out. Now I have grams. Now I can use the density as a conversion factor. So this time, since I have grams on the top, I'm going to put grams on the bottom. So 0.9982 grams goes on the bottom. 0.9982 grams on the bottom and 1 milliliter on top. So grams cancels out. Now I have volume in milliliters, but I want to convert that to liters. So one more step. I know that 1,000 milliliters is equal to 1 liter, or 1 milliliter is equal to 1/1000th of a liter. Either one works. So I'm going to put 1 milliliter on the bottom, and I'm going to put 1/1000th, 10 to the negative 3 liters on top. So milliliters cancels out. And now I have liters. So all I need to do is calculate it out. And when I do that, I get 25.05 liters. And so again, since I'm multiplying and dividing, my answer should have the same number of sig figs as the least number of sig figs, as the measure with the least number of sig figs. And so here I have 4 sig figs. This is exact, so I can ignore that. This is also exact, so I can ignore that. And this also has 4 sig figs. So 4 is the lowest number of sig figs. So therefore, my answer is in 4 sig figs, has four sig figs. Okay, number 3. What is the mass in kilograms of 15.6 gallons of gasoline? So they're giving me the density. The density of gasoline is 0.70 grams per milliliter. So I'm given a volume in gallons, and they want mass in kilograms. So I'm going to have to convert gallons to milliliters, so that way I can use the density as a conversion factor to convert milliliters to grams, and then convert grams to kilograms. So I'm going to start with gallons. They give me 15.6 gallons over 1. So I need to convert that to something that I can get to the milliliters. So let's convert that to liters. So 1 gallon, give me a moment here. So 1 gallon is 3.75, what is it? 3.78541. 3.78541 liters. So 1 gallon on the bottom, and then 3.78, was that 78541, and that's liters. So gallons are going to cancel out. Let me double check I got this right. 1 gallon, yes. So now I have liters. So now I'm going to convert liters to milliliters. So I know that 1 liter is equal to 1,000 milliliters, because a milliliter is 1/1000th of a liter. So it's going to take 1,000 of them to equal a liter. So liters are going to cancel out. Now I have milliliters. Now I can go ahead and use the density to convert to grams. So since I have milliliters on the top, I'm going to put 1 milliliter on the bottom. So 1 milliliter on the bottom, 0.70 grams on top. So milliliters cancels out. Now I have grams. I have a mass unit, but they want kilograms. So I got one more step. I'm going to, excuse me, I'm going to convert to kilograms. I know that 1 kilogram is 1,000 grams. So I'm going to put 1,000 grams on the bottom. That's going to cancel out. And 1 kilogram goes on top. So now that I have kilograms, which is what they're asking for, I'm done. So all I need to do is just calculate the answer. And when I do that, I get 41 kilograms. 41 kilograms. Let me double check. That is correct. So Again, notice the sig figs, I have 2 sig figs. That's because the least number of sig figs in my measurements is 3, or is 2. So I have 3 sig figs here. I have 5 here. This is exact. This is 2, and this is exact. So 2 is the least number. So my answer has 2 sig figs. Finally, last but not least, what is the volume in liters of 242.6 metric tons of iron? And we're given the density of iron is 7.86 grams per milliliter. So they're giving us 242.6 metric tons. So we'll start with that. So 242 T for metric ton over 1. And so since this is a mass, we're going to have to convert metric tons to grams. So that way we can use the density here to convert to volume in milliliters. So we need to get to grams. So first we need to know what the relationship is of metric tons to something. And that is 1 metric ton is equal to 1,000 kilograms. So we'll put 1 metric ton on the bottom and 1,000 kilograms on top. So metric tons cancels out. Now I have a kilograms on top. Now I can convert that to grams because 1 kilogram is 1,000 grams. So I'm going to put that down here. So 1 kilogram is going to go on the bottom. And 1,000 grams goes on top. So now kilograms can cancel out. And now I have grams. So now that I have grams, I can use the density to convert grams to milliliters. So let's go ahead and do that. Okay, so I have grams on top. So I'm going to want grams on the bottom to cancel out. So that's going to be 7.86 grams on the bottom and 1 milliliter on top. So grams now cancels out. Now I have milliliters. And what are they asking me for? What is the volume in liters? So I just need one more step to convert milliliters to liters. So I'm going to use the conversion factor that 1 liter is equal to 1,000 milliliters. So 1,000 milliliters goes on the bottom and 1 liter goes on top. And I have milliliters cancel out. So now I have liters. So all I have to do now is calculate. So when I do that, I get 30,865. So 30,865 liters. Now, I haven't properly rounded this yet because I want to kind of show you something that is important to understand. So here, this is my answer I get from the calculator. I get a few more digits, but this is enough for the purposes of what we're showing here. So now I have to round this to the nearest number of sig figs. So again, when we're multiplying and dividing, the answer should have the same number of sig figs as the least number of sig figs in your measurements. Now here I have 4 sig figs. This is an exact relationship. This is also exact. Here I have 3 sig figs, and here it's exact. So I have 3, 4. So the least number is 3 sig figs. So that means that this should only have 3 sig figs. But right now I have it written as having 5 sig figs. So I need to only have 3. So that means that I can keep the 3 here, the 0 there, and the 8 there, and I got to cut off the rest. Now, a lot of students, when they first learn this rule and they run into this problem, they'll do everything correctly. They'll keep the first 3. Then what they'll do is they'll write, okay, my answer is 308, and there, I'm done. 308 is the answer. And then when I say they're wrong, it's like, well, Mr. Caldwell, it's 3 sig figs, right? This is 3 sig figs. And I'll be, yeah, that's 3 sig figs, but that's not how you do it, right? So the reason is look at this answer. This is 30,800 or 30,865. 30,000, right? This is 308. There is no way in the world that you're going to round your answer that much to go from 30,000 to 300, right? So you got to think logically about this. So we want to round our answer, but we want our answer to be close to what the calculated answer is. And so what we do here in this case is that these two digits that we dropped have to be replaced with zeros. And so our answer would be 30,800. That would be the correct answer. And notice it's still 3 sig figs because the zeros at the end of the number do not count unless there's a decimal place. So you don't want to write a decimal place. If I put a decimal place there, I still have 5 sig figs, but we don't want the decimal place. So if I take away the decimal place, then the 3, the 0, the 5, these are all significant, but these zeros are not significant. So we have 3 sig figs here. And so that's how you get that answer. So I hope this video is helpful in helping you understand how to use your conversion factors, especially density as a conversion factor, and hopefully help you to understand the sig figs and how to determine the sig figs of your answer, especially for this kind of thing that happens relatively often. So that's it for this video. Thank you very much for joining me. I hope this video helped you. If you like this video, if this helped you in any way, then please by all means like the video, share the video, hit that like button. Also subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below, right? Put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a particular question or problem you would like me to help you with, then put that down below. I would love to help you with that. Thanks for joining me and have a great day.